subjective probability things. A father having hazel eyes and a daughter having hazel eyes. This would kind of be a dependent event. Obviously she inherits the genes and the traits from the parents. So this is a dependent event. Does it mean she will have hazel eyes? No, because you probably learned in science how they match up and you figure out your strands there. But it has a dependency. Number 13, rolling a 6-sided die, and then rolling the die a second time so that the sum of the two rolls is 5. Normally rolling a die and rolling a die a second time is no dependency, but you needed the sum to add up to 5. So there's a dependency there. It depends on what you got the first time, right? You have to count that first roll. Everybody see that one? That was kind of tricky. Normally rolling a die is usually independent, but this one depended on the other. A quick way, by the way, to figure out sums of die is what are your choices when you roll a die? 1 through 6. And if you roll a second die, 1 through 6. Now, there's a pattern when you do your sums. 1 and 1 is 2, 2 and 1 is 3. Here's your pattern. 2 and 1 is 3. See your pattern? These are the sums. These are the sum of two dice when you roll your die. So look at your diagonal here for 7. There's your 7. You know, like when they play craps and they say 7 or 11? 7 or 11, that's mutually exclusive. The 7 happens the most times for a sum. It's on your diagonal. The 11 happens twice, but a 7 happens 6 times. 6 out of 36 times is 1/6 of the time. That's the number the sum that will come out the most. The snake eyes, only 1 time. Only once over there. So if you're going to have to figure out sums of things, this is a good way to do it.
So like when you're playing Monopoly, you get like three like double. That's what are the odds?
What are the odds of that? Exactly. What are the odds of that? Your doubles. Where's your doubles? 2, 2, 3, 3. Here's your double row right here. See it? Your column right there. There's 6 out of 36 times. 1/6 of the time you can get a double. When you play Monopoly, also, like if you have to get out of jail, what do you have to roll? 2 snake eyes? Is it snake eyes? Or any double?
Any double.
Okay, so you have a 1 out of 6 chance of getting your any doubles. So this is a good way to figure out your card things. Just a little sidebar. A study found that people who suffer from moderate to severe sleep apnea are at increased risk of having high blood pressure. Your 2 events, and they're independent of each other when we start, we just name the 2. Having moderate to severe apnea and having high blood pressure. Those are the 2 events. Do they have an effect on one another? Yes. People who have moderate to severe sleep apnea are more likely to have high blood pressure. Anxiety, they can't sleep. It has a dependency. This is one of those like subjective dependencies. Can we exactly pinpoint what the dependency is? No, but we know that it has a dependency. A study found that there is no relationship between being around cell phones and developing cancer. The 2 events are being around cell phones and developing cancer. And in this case, they're not related at all. They are independent of each other. Because they specifically tell you cell phones do not cause cancer. Number 21, this wasn't a good one to do, not a good situation, but a good one to do. 1 in 400 women carry a mutation of the BRCA gene. 6 out of 10 women with this gene, if it is present, will develop breast cancer. So what is the probability that they carry the gene and develop breast cancer? Remember, the and is the multiplier. 1 out of 400 times 6 out of 10. So even that way, it is a small chance. If you move your decimal place, it's a less than 1. It's like 0.2%. Everybody okay with this one? First have to decide if they were independent or dependent. In a sample of 1,000 U.S. adults, 1,000 is your bottom number, 180 dine out at a restaurant more than once a week. So your probability that you dine out more than once a week is 180 out of 1,000. Keep it as a fraction if you have to reduce it at all. You can't reduce a decimal by subtracting 1 off of it. It doesn't work that way. Find the probability that both adults dine out more than once per week. But they told us they selected the adults at random without replacement. That means when they picked one, they left him out of the mix there. They picked another. So your bottom number has to change. And as a result, your top number changes. So the first adult, 180 out of 1,000. The second, one less, 179 out of 999. And you multiply. And you've given me 3 decimals on your probabilities. And you're rounding correctly. Yeah. On all probabilities, 3 decimals. Because if we flip these two percentages, at least you have a decimal in your percentages. Not like saying exactly 67%. Find a probability that neither dine out more than once a week. So go for your complement situation. 1,000 minus 180 is 820. So start with 820 over 1,000, then reduce both by 1. Your probability that at least one of the two dine out, so you either want 1 or the 2, but you don't want the none case. So we subtract out the none, that neither eat out. And which one is considered unusual? Well, the book considers anything less than 5% unusual. I think that's really low to begin with, like even 10% I would consider kind of on the unusual side, but the book considers anything less than 5%, and it's because of the way we do your curves at the end, you'll kind of see how it ties into that. That's at your plus or minus 2, what's left on your side. So. Okay. Same type of setup this was. You're selecting your 2 adults out of 2016, 3 of the 83 out of 2016. There's your probability that they said Roosevelt was the best president. And they're taking them without replacement. Okay. So the first one times the second one. Then neither, do the complement case.
What's the one where you like take it? Adult and the less than 1, and then adult.
The
At least
less
one,
than,
at least one.
at least one.
Would you just subtract the, what you like, the 0.036 and
Okay. Okay, so what that one says is, now that's a good question. This one says that both. When you're in it at least one, you can have one or both. You have to have both of these conditions. So both, yes, I want the both. But I also want, what if just one picked? Yes. So
that we subtract like the 0.036 from 1.
no, not from one. Not from one. You come here and you say the only condition I don't want, you don't want neither. You want everything else but neither.
Oh, you subtract that from 1.
So subtract that from one.
Oh, gotcha.
Right,
Yeah,
because the at least says you can have one or you can have 2. Kind of think back to, remember in Algebra 2 we did that? We said like if you had 5 days you went on vacation, 30% chance of rain. What is the probability that at least 2 days it rains? 2 or more?
So why is it 382 and not like 381?
Yes. So the first time around you have that's the first person. Then we remove that person and we take one away. You took one away before you started, right? Yeah. And the one that's unusual is the one that's less than 5%. This guy's about 3.6%, so they consider that unusual. It's just a small probability. That's what they mean by unusual. Okay, the blood types, guys. person in the U.S. having a B positive blood type is 9%, 0.09. That's I consider that on the rarer side too. That's a little bit on the unusual side. 5 unrelated people are selected at random. Okay. Now, when we check them, are they dependent on each other when we check their blood type? My blood type is not dependent on Leslie's blood type, right? Or Daniel's. We're all independent blood types. So when you pick 5 people, the probability that they will all have B positive is very, very small, 0.09 to the 5th power. Okay. Now your calculator probably gives you 5.9 e to the negative 6. Remember, this is your scientific notation number. Move that decimal 6 positions to the left, so you're getting 5 zeros after your decimal. Find the probability that none of the 5 have a B positive. Use your complement case for your 0.09 first. And this is your 0.91 to the 5th power. And the probability that at least 1, that means 1, or 2, or 3, or 4, or 5, the only one that it cannot be is none. So subtract the none of these from that, from 1. And so, considered unusual, all 5, that would be, the book doesn't really consider under 5%, but that's way under 5% personally. So that's unusual. It's all 5 people have B positive. Okay? Yes. Yes. Base pair, you have to know this? No? But I thought it'd be nice and challenging to put this in your calculators. Yes. So the thing with your calculators is you can also use your fraction key. It's alpha y equals. That will get your fraction key. And within a fraction, you can throw in another fraction key. So when you get to the denominator, or in the numerator, you might want to throw in another fraction key. And just plug them in like that. If you were to do this without your calculator, make sure that this has parentheses without your fraction, and make sure this has parentheses, and this guy has parentheses. It's far easier to do with a decimal. I gave you one for a decimal, one for a fraction. Make sure that's hooked up, make sure that's hooked up. And do you have to know that? No, but it's kind of just a good calculator thing for you guys to try. Because I know you...
Mutual is the same.
Mutual is the same.
Exclusive is like you.
Excluding, like, yes, so they can't happen at the same time. Mutually exclusive says, that was a very good way to take it apart tonight, very good way. Mutual is the same, agree, exclusive, excluding. So, this means these cannot happen at the same time, and this is extremely important. So say I'm filling out a questionnaire, or you're filling out a questionnaire, and they want your age bracket. And they say 0 to 10, they say 11 to 20, they say 21 to 30, and you have to put a little box and check off where you fall. Can you check off more than one box? No, they're mutually exclusive. You could either be like 16 or 15 in this group, but you can't be 16 and 26 at the same time. You can't fall into 2 different brackets. So those age brackets are mutually exclusive.
What if you're 10 and a half?
You're 10 and a half, you will probably have to go in the 10 box because you're not yet 11. Not yet 11. Okay. All right. So, the addition rule says, if 2 events, A and B, are mutually exclusive, they cannot occur at the same time. Mutually exclusive. You could either be 60 years old or 26, but you can't be both ages at the same time. You could either have a blood type of B positive or a blood type of A negative, but you can't have both at the same time. Mutually exclusive. What if I ask for all seniors and all females? Is that mutually exclusive? No, because what? You can be both. You can be a female senior, right? So that is not mutually exclusive. Mutually exclusive means they can't happen at the same time. If I ask for all senior females and all senior males, is that mutually exclusive?
Yes.
Yes. Okay. So we're going to decide if these events are mutually exclusive. And I'm on page 157. It's in your notes. Yes.
If you're a male, if you're male, and you're senior female, aren't those two different names?
Exactly.
But they,
Can you be both at the same time?
Yeah.
Can you be a senior male and a senior female at the same time?
you can't be a male and female at the same time.
You're right. But you
Yeah.
can be a senior, right?
But but they're occurring at the same time, you call them both groups.
Good question there. Good point there. But what we want to do is say we're adding up all the votes that the senior males made and all the votes that the senior females made. Can I add those together knowing that there's no overlap? So they're mutually exclusive. The fact that I said senior male, senior female, even though I used two things at the same time, it's still one group. One group, one group. They can't switch groups in the middle. You can't check off both groups. Like if it says senior male, senior female, you have to pick one box, right? Okay. So, decide if these are mutually exclusive or not. Event A, you roll a 3 on the die. Event B, you roll a 4 on the die. Are they mutually exclusive? Because can they happen at the same time?
No.
No. So those guys are mutually exclusive. Okay. Number 2, you randomly select a male student. From the same group, you randomly select a nursing student. They're not mutually exclusive? Why?
Like a nurse or could be a nursing student.
Because you could have a male that is a nursing student. Good. This is different. Okay, I get something new and exciting on my board. Okay. You randomly select a blood donor with type O blood. And event B, from the same group, you randomly select a female blood donor. Are they mutually exclusive?
No.
No, because I can get a female who has blood type O, right? So these are not mutually exclusive. Okay, so that's important that we can figure out if they're mutually exclusive or not. Take a minute and decide these. Just read them and decide them. Huh? You got one right? A face card is a jack, a queen, and a king.
So those are mutually exclusive.
Right. They're not.
One is not. Two it is.
Because the jack comes with a card. So you get a jack and you should choose a card.
So you can check.
You can, if they're mutually exclusive, they can't happen at the same
So
time.
one is
Oh, okay.
Yeah, always say that first, because when you use a not word, it gets confusing. So go back to the regular word. Mutually exclusive can't happen at the same time. So event A, you randomly select a jack from a standard deck of cards, and at the same time, event B, you randomly select a face card from a standard deck. Are they mutually exclusive? Which card happens in both? A jack. Okay, and this is important when we go to add this. I ask for a jack here, and I get a jack here. So if I'm counting all my cards, watch. How many jacks in my deck? 4. How many face cards in my deck? 12.
No, 12, 4 times.
4 times 3.
I was
Right? Now, if I add these together, I get 16. However, I counted the jacks twice. I counted them here, and I counted them here. So that's a problem, because these are not mutually exclusive. So we're gonna see when they're not mutually exclusive, you can't add like you normally would if they are mutually exclusive. Okay, we're gonna get to that in about 2 seconds, 2 minutes. Okay, you randomly select a vehicle that is a Ford. Rachel, you randomly select a vehicle that is a Toyota. Is it mutually exclusive?
Like, this is the last time, I was asking why the answer was number one. I didn't understand.
The answer for number one, if it's mutually exclusive, you can't get the same result in event A that you get in event B.
So just because both of them have Japanese names.
Then they're not mutually exclusive. They overlap, right? Because out of all my face cards, 4 of them are Jacks. Yes. Number 2 is mutually exclusive because they cannot happen at the same time. I can't choose a car that is a Ford and a Toyota at the same time. Okay. Now, here's your additional. Stick with me for a second on this. The probability that event A or B, I should say or B, not of, or B will occur, A or B, is given by this probability. I take the probability of A, I add the probability of B, and I subtract the probability where they overlap, where they're both. These events are mutually exclusive, but for when these are not mutually exclusive. Okay? If they are mutually exclusive, a Ford and a Toyota, I just have to add how many cars are Fords, how many cars are Toyotas.
That's if they're not mutually exclusive.
This one is if they're mutually exclusive. The first part is if they're not mutually exclusive. The second part is if they are mutually exclusive. Then I just have to add them together.
Picking up what you put down in the first one.
Okay.
Probability of A or B.
The probability of events A or B will I must have messed up this whole sentence. Be the probability of A or B given by this probability. I probably skipped the whole sentence. Is the probability of A plus the probability of B minus the probability of A and B. Okay. The probability of a jack plus the probability of a face card.
Oh, yeah.
Okay, now watch. Is this mutually exclusive?
Yeah. No.
No, because what happens? Jacks occur here, jacks occur here. So, how many jacks do we get? How many face cards? But how many did we count twice? 4. I counted this here and here. I can't count them twice. So the answer would be 12. And or says to add.
Oh, yeah.
And or says to add them together. Okay, let's break this down a little simple. I have a die. Okay, hang on. I have a die. 1, 2, 3, 4, 5, 6. I want the probability of a number 3 or an even number.
That's mutually exclusive.
Oh, they are mutually exclusive.
You
so
just
they-
said odd number.
Okay, but I'm going to change that in a second. But, so 3, they can't occur at the same time, right? So, 3 is what I want. And which ones are even? 2, 4, and 6. So how many do I end up with? 4 out of what? Because I added them together. I took the probability of a 3 plus the probability of an even. The less, here's my, I didn't want to move this too far. Here's my one, God bless you. Probability of A plus the probability of B. So I got 1 plus 3 over 6 over 6 is 4 over 6. Mutually exclusive. Good? Now, there's my die. And as Damani said, I want a 3 or an odd number. Now let's go to your numbers first. I want the 3. And I want to add in any odd numbers. What other numbers do I want to include? 1, and 5. So how many do I get? 3 out of 6. So stick with me a minute. Probability of a 3 plus the probability of an odd, and let's see what happens. 1 out of 6 plus how many odds? Now that would give me 4 out of 6. Yet we only got 3 out of 6. You take out the 1, good, because minus the probability of A and B. Which one is a 3 and an odd? There's one of them. So see my addition rule? Daniel?
So the probability of A and B is always the equals the probability.
No, the probability of A or, we're going to add them together if they're mutually exclusive. We're going to add them together and subtract where they overlap. In this case, there was one overlap, but not always. Let me give you, before you pack up, guys, Daniel's asking a very good question. So let's think of another example here. A probability of a red card or a king. Okay. Is there any kings that are also red? Yes. So are these mutually exclusive?
Yes.
No. So I got the probability of a red card. Wait. Minus when it's a red and a king.
It'll be 20.
So how many red cards? 26 out of how many kings?
2.
All together, how many kings?
Oh, 4.
4 out of 52. How many of those kings are red? 2 out of 52. So in that case, it's not the same. It just so happened the example I gave you was the same.
So it'll be 28.
So this would be 28 out of 52. Okay? Tomorrow, we'll finish this up and hit this again with the mutually exclusive thing. That is the temper card.